Okay, so let's see how we're going to use those factorial skills. We're going to look at permutations. Oh my goodness, look, we got a bunch of children, and there's only one available swing. All right, so let's start with 3 children, and they're waiting for that swing. Order matters, right, because they're in line, because whoever is first in line gets to be able to swing next. So how many ways could these 3 children line up? Okay, well, we could have Albert, then Betty, then Clyde, or Albert, then Clyde, then Betty. Betty could be first in line, with Albert and Clyde in different positions, or Clyde could be the first one in line. Aha! 6 ways we can line up 3 children if the order matters. Okay, oh hey, there are 4 kids this time. How many ways could 4 kids line up? Oh my goodness. Having a 4th person in that line creates a much, much larger sample space, right? There's 24 ways of lining up 4 children if the order matters. So I've got 7 children here. I've got Albert, Betty, Clyde, Debbie, Eratosthenes, Francine, and George. They're all waiting for that swing. How many ways could they line up? There's no way I'm going to be able to list these. Well, I mean, I could list them, but I'd be spending hours upon hours typing organized lists. So let's think about this. 3 children resulted in 6. Hey, that's 3 factorial, right? 3 times 2 times 1 is 6. 4 children, well, we found 24 ways. That's 4 factorial. 4 times 3 times 2 times 1 is 24. So if I want 7 children, it'd be 7 factorial, which means there's 5,040 ways that I could line up 7 children if the order matters. Right? If it depends on who's actually first, who's second, etc. So that's what we can do with factorials. Oh, a roller coaster. Who doesn't like to ride on a roller coaster? Ooh, the last car has 2 seats available. Now the order matters here, right? Because one person has to climb in first, and then the other person gets to climb in second. So we've got 5 people that really would like to take that spot in that last car. So we got Albert, Betty, Clyde, Debbie, and Eratosthenes. And there's room for 2 of those 5 people. Well, Albert could be first, followed by one of the other children. Betty could be first, followed by one of the other children. Clyde could be first, followed by another child. Debbie could be the first one in, followed by someone else. Or Eratosthenes could be the first one in, followed by one of their children. So there are 20 ways that 2 of the 5 people can be seated in the car if the order matters. Okay, so we know there's going to have to be a shortcut. And it's probably got something to do with factorials. But the name of this lesson was permutations, right? So there's a shortcut, but it's going to involve permutations, right? So if there are n things, and they're taken r at a time, so notice that p does not mean probability. That p is for permutations. Sometimes we reuse letters in math. So p of n comma r is going to be n factorial over n minus r factorial. Now again, this will often make more sense if we see it with numbers instead of alphabet soup. So let's go back to the situation where we had 5 people, and we were going to select 2 of them, and the order mattered. So in our case, n is 5, right? We had 5 things. R equals 2. We want to select 2 of them. So the number of permutations, it's going to be 5 factorial in the numerator, 5 minus 2 factorial in the denominator. And of course, 5 subtract 2 is 3. You say, aha, this looks like one of the skills we practiced in the previous lesson. Right? Sometimes we had a fraction and there was just 1 factorial on the top and just 1 factorial on the bottom. And so sure enough, this is a skill we had practiced. In this case, we call this a permutation. Of course, we can do a lot of canceling. 5 times 4 is 20. And of course, that's what I had when I made the list, right? And when I made the list, I found that there were 20 different ways of taking 2 out of those 5 people. Ooh, the local ice cream parlor. They happen to have 10 flavors of ice cream available. I'm thinking it'd be really nice to have 3 scoops on a hot day like today. Yeah, like it's really hot out there today. Let's pretend it's a hot day and I really want a big ice cream cone. I want 3 scoops. I want each scoop to be different flavor. And of course, the order matters because the flavor on top, that's the one I'm going to start with. Right? When I started looking and eating my ice cream cone, whatever flavor is on top, that's going to be the first one I encounter. And then I'll move on to the middle scoop of ice cream, and then finally that bottom scoop of ice cream. So, how many possible ice cream cones can I order? Assuming that each scoop must be a different flavor. Well, there are 10 flavors. I want 3 of them. So, numerator, 10 factorial. Denominator, 10 minus 3 factorial. Of course, 10 minus 3 is inside parentheses, so I do that first. I get 7. And of course, I'm just going to end up doing 10 times 9 times 8. And that's 720. So, believe it or not, if there's 10 flavors of ice cream, and I want 3 different flavors scooped on top of each other on a cone, there's 720 ways to have that done. Now, today it's not going to be in the form of story problems. Today it's just going to be, hey, let's just practice these things. So, here's one example, right? Permutations of 9 objects taken 4 at a time. So I plug in the numbers 9 and 4. 9 minus 4 is 5. So I need to do 9 factorial over 5 factorial, which means I need 9 times 8 times 7 times 6. And I might actually grab a calculator for that one. Most of these I've been able to do in my head, but this one I'd probably want a calculator. Here's a different example. Permutations, 10 objects. I'll only take 1 at a time. Hey, there's not much going on here. It's just going to be 10. Right? Of course, if I just take 1 at a time, there's only 10 different things I can grab. What if there's 4 things, and I want to take all 4 of them? Aha! We finally encounter our friend 0 factorial. Right? This is why mathematicians have defined 0 factorial to be the number 1. Right? So if there's 4 objects, and I want to take all 4 of them, there's 24 ways of doing it, right? That's just 4 factorial. Because I'm not leaving anybody out of the group. Alright, so we'll try to keep this video down to 10 minutes or maybe even a little bit less as our worksheet flies in to another one of our stunning sunsets. Okay, have at it, folks.